Hey guys, welcome to Cynohub. Today we are discussing a new topic, quantization. So in digital communication, we use the quantization concept. For example, if you consider a voice or image or video. Okay, so these are occurs in the analog format only. But in the digital communication, all the information is in the form of analog. But in digital communication, we transmit the data in form of digital. Means we need a analog to digital converter. So we need an analog to digital converter. For example, if you consider different types of analog to digital converters, first one is PCM. Okay, so pulse code modulation is the basic technique to convert the analog signal into a digital signal. Now, look into the block diagram of the pulse code modulation. Analog input, sample and hold circuit, quantizer, and next one encoder. Okay, so data is in form of digital after the encoder. Okay, so this is the block diagram of pulse code modulation, or nothing but a block diagram of analog to digital converter. So in this, let's consider the analog input and it is applied to a sample and hold circuit. So sample and hold circuit means it acts as a switch. So sample and hold circuit nothing but it acts as a switch. For every time duration Ts, it's turned on to on and off. If it is on, the instantaneous, the present sample is appear as the output of the sample and hold circuit. Okay, the sample and hold circuit output is applied to the quantizer. Means the quantizer is used to, for example, if you consider the first one analog input, so this is the analog input. It is applied to a sample and hold circuit. The output of the sample and hold circuit contains the discrete samples. For every t seconds, it's once turned on and off. Okay, so this is the output of the sample and hold circuit. Okay, so next one is quantization. So quantization means it is round off to the nearest integer values. In general, the samples, output of the samples contains the discrete values, nothing but 1.2, 2.1, 2.7 or 1.9 like that. But in digital, we are only discussing about the digital numerical values, nothing but 0, 1, 2, 3 so. Okay, therefore, we round off the nearest integer value. Okay, that is the working of the quantizer. Okay, for example, if you round off the quantizer, the output of the quantizer contains the so this is the output of the quantization, means it round off the nearest two integers. Okay, for example, next one is encoder. So encoder means it generates the corresponding digital data to the corresponding each sample. Okay, for example, if you consider a 3-bit encoder, it generates 2 power 3 possibilities. Means 8 possibilities. So it generates the So it generates the equivalent binary data to each sample. Okay, so this is the working of the encoder. Okay, so the quantizer is classified into two categories. One is uniform quantization and second one is non-uniform quantization. Okay, so in uniform quantization, the step size is same or step size are equal. In non-uniform quantization, the step size is varies with respect to the input signal. Okay, and the uniform quantizer is divided into two ways: mid-tape and meterize. Okay, so uniform quantization is divided into two ways. First one is mid-tape and second one is meterize. Okay, so these are the different types of quantization techniques, and the error occur in the quantization is called quantization error. The error occur in the quantization is called quantization error. The quantization error means if you round off the integer value, for example, if you consider 1.9, it equating to 2, means the difference is plus 0.1. Okay. Similarly, for example, if you consider sample 1.6 is equating to 2, means here the error is plus 0.4. So these values are called as the error values, and the errors are occur in the quantization. Therefore, this is called as the quantization error. The quantization error is in the range of minus delta by 2 to delta by 2. So quantization range is in the range of delta by 2 to delta by 2. Here delta indicates the step size. Here delta indicates the step size. So therefore, step size delta is equal to Vmax minus Vmin by 2 power n. Therefore, the step size delta is equal to Vmax minus Vmin by 2 power n. Here n indicates the encoder size. In this condition, n is equal to 3 because we consider a 3-bit encoder. Okay, means in this condition, the step size, for example, if you consider a sinusoidal waveform with the maximum amplitude of 4 volts and minimum amplitude of minus 4 volts, in this case, the step size delta is equal to Vmax minus Vmin by 2 power n, here n is equal to 3. Therefore, 8 by 2 power 3 is equal to 8 is equal to 1. Therefore, here step size is equal to 1 volt. Means the quantization error is in the range of minus 0.5 to 0.5. Okay, so therefore, the quantization error is in the range of minus 0.5 to 0.5. Okay, the only way to reduce the quantization error is increasing the encoder size. Okay, for example, if you want to reduce the quantization error, the only way is to reduce the and increase the encoder size. For example, in the same example, if you consider the encoder size is 4, okay, then Vmax minus Vmin by 2 power n is equal to Vmax minus Vmin is equal to 8 by 2 power n. 2 power n is equal to 4. 2 power 4 is equal to 16. Means step size delta is equal to 0.5. Okay, so if you consider encoder size 4, the step size is equal to 0.5. Means the quantization error is in the range of minus 0.25 to plus 0.25. Okay, so by using the encoder size, by increasing the encoder size, we reduce the quantization error. But the main drawback of by increasing the step size, encoder size is it requires the more data to store the information. Okay, so this is about the quantization. So I hope all of you understand what is the quantization and what is the quantization error and what are the types of quantizations. So I hope you understand, and I will meet in the next session.